Oh no, I am not recording this. So annoying.
That input component dot
You don't need to include this, but I will. He's doing it.
h is not going to be included more than once. And there go the squigglies, they're gone. So now we know this move function will be called every frame, and value will have a particular float value, depending on whether we're pressing the W or S keys. Now, simply knowing that the move function is bound to move forward is not quite enough. As developers, it's nice to have some sort of confirmation that things are working. So what I'd like you to do as your challenge is to use uelog in the move function to print the value that's being passed into move, that float called value. So use %f in uelog to log the value of the float value to the output log, and then playtest the game and press those keys and see what you get printed out to the log. Pause the video and add this to the move function now. Okay, so here in the move function, I'm going to add a uelog, and this can be log temp, warning, and for the text macro, I'm simply going to put value, %f, and value. Now that's okay if you used a different verbosity or
Be great if I could spell. Okay, so this is not moving.
warning type, if you know how to do those things, that's totally fine. I'm just going to use a warning here. And I know you've used things like %s and formatted your log with a string value. %f, if you're not aware, is how you can format your UE log with a float value. So let's compile this. And back in the editor, I'm going to open up the output log and press play. And check it out, we're spamming the output log with countless messages.
Oh, finished. Okay. Oops. Let's say warning. And now live build. Live code. Succeeded. Okay. Output log. Good. Got this in layout. All right.
Now I'm going to click in the viewport and press the W key. There's my value of 1. I'm going to release. It's back to 0. I'm going to press the S key, and it's -1. And if we press both at the same time, we get 0. And so it's exactly as we expected. Perfect. All right, so in this video, we've set up our pawn to handle some user input. We talked about axis mappings, and we bound our move function to the move forward axis mapping. We then printed that axis value using uelog in our move function. But we'd actually like to move our tank rather than just print some values to the output log. So in the lectures to come, we're going to set it up so that we can actually start moving our tank. I'll see you soon.
I'm freaking halfway through.
Hello and welcome back. Now in this video, we're going to start talking about how we can move our tank. So to move the tank, we're going to have to add some sort of offset. And in Unreal Engine, when it comes to adding an offset, we need to make the decision whether to make the offset in local space versus world space. So let's discuss the difference between these two things. Now here in the editor, I have the pawn tank selected. And as soon as I have this selected, you'll notice that there is a gizmo. That's what this thing is called, a gizmo. It has 3 arrows and they're each a different color. Now, if you haven't noticed, at the bottom left of the screen is another smaller gizmo. And this sort of looks similar to the gizmo on the actor that we're selecting. So if I select any actor, we always get this gizmo. And of course, the gizmo changes when we go from translate to rotate to scale mode. So as long as we're in translate, which we can access from this leftmost icon at the top right of the viewport or with the W key, we have the ability to move things or translate them by dragging on one of the arrows on the gizmo. And the colors correspond to the axes. Red is the x-axis, green is the y-axis, and blue is the z-axis. Now, if we rotate our view and look in a different direction, we'll see that that gizmo still points in the same original direction, and as we're rotating around, the gizmo at the bottom left of the viewport is rotating because the world direction does not change. So far, so good. Now, what we're looking at is world space directions. But for each actor in the world, there is a local direction, and we can see that by clicking on this icon that looks like a world, and the pop-up says cycles the transformed gizmo coordinate systems between world and local space. When we see a world here, that means we're looking at world space. But if we click on it, it now turns into a cube, and we're now looking at local space for the given actor that we have selected. The gizmo at the bottom left of the viewport still shows us world space. But if I take this actor and I
Wait, I completely missed that.
Local space for the given actor that looks like a world, and the pop-up says cycles the transformed gizmo. Each actor in the world, there is a local direction, and we can see that by clicking on this icon that looks like a world, and the pop-up says cycles the transformed gizmo coordinate systems between world and local space. When we see a world here, that means we're looking at world space. But if we click on it, it now turns into a cube, and we're now looking at local space for the given actor that we have selected.
Distracted. Oh me, oh my, this actually works. All right, distraction over.
The gizmo at the bottom left of the viewport still shows us world space. But if I take this actor and I switch to rotation mode and rotate it, then when I go back to translation mode, you'll see that the gizmo is now pointing in a different direction. The actor, it's
Interesting.
itself has its own local x-axis. We can think of the x-axis for the actor as its forward vector. Now notice that at the bottom left of the screen, that gizmo is still pointing in the same direction. But this actor here, the pawn tank, has its own local x direction and it's pointing in a different direction. Now if I click on the cube here and turn it back into a world, now the gizmo for the tank is matched up and aligned with the world axis direction. So we can switch between world and local space for any given actor to see its local direction versus its world direction. So we've seen that for any actor that we select in our world, it has its own local direction, and this may or may not be different than the world direction, as indicated in this image here. So this is very important when it comes to moving objects. In Unreal Engine, there are functions for moving objects, and there are a different set of functions for moving in world space versus local space. Let's say our tank is facing this way, and its x-axis is pointing slightly to the left, as indicated by the arrow that I've drawn here on the tank. Now we can see, based on this gizmo to the bottom left, that the world x-axis direction is pointing to the right, so the tank is not aligned to the world space direction. Now say we were to move this tank in world space in the positive x direction, then even though the tank is pointing to the left, it's still going to move in that world x direction, and it'll look like it's moving backwards, so that's not what we want. Now, on the other hand, let's say we use a function that's designed to move the tank in its own local space. That means if we move the tank in its own local x direction, it's going to move forward in the direction you would expect, and that is the behavior that we want. Now, in Unreal Engine, the function that can do this for us is called addActorLocalOffset. This function moves the actor in a local direction. Now, it applies an offset, which is a single movement. Essentially, we tell it which direction to move and how far, and it moves that object once, which means we're going to call this function every frame that we want to move the tank. So we're going to be moving it in small increments, since calling a function every frame means we're calling it a lot. Now, for our tank, its own local x-axis is its forward direction. So this is the axis we're going to use when we add a local offset. Now here's the Unreal Engine documentation for addActorLocalOffset. You see that it's a function that belongs to the actor class. That's why it's called addActorLocalOffset. Now because it exists on the actor class, pawns will inherit this function, so we can use it. Now here's the syntax. It has 4 input parameters. The first is an f vector called delta location. So we're going to need to create an f vector that we can pass in to this addActorLocalOffset function. So we know about this addActorLocalOffset, and I'd like to experiment with this just to see how it works, so we can do this in the tick function. Now we are not overriding the tick function here in the tank class, but we do have it in the basepawn class. If we go to basepawn.cpp, here we have the tick function, and we're not doing anything here, and this is perfect to do some experimentation. So what I'm going to do is type addActorLocalOffset, just like that, and I'm going to right-click and select Go to Definition. Now here in the actor.cpp file, we have the definition for addActorLocalOffset. Now notice something interesting.
Sorry, getting distracted. What am I doing? We are in tick. I think, is this better? Test. I don't want to shout. Oh, this is actually...
Select Go to Definition. Now here in the actor.cpp file, we have the definition for addActorLocalOffset. Now notice something interesting. It's checking if root component is not null, and if it's not null, then it calls this function addLocalOffset. So really what we're doing is adding an offset to the root component, and since all other components are attached to the root component, they'll move along with it. So it's important to note that when we're adding a local offset, we're moving the root component, and everything else just moves with it. Now if we hover over addLocalOffset, we'll see that all 4 of the input parameters are listed here, and aside from the first one, which is an f vector, the others have default values. Notice bool b sweep. It says equals false. The 3rd and 4th input parameters also have these default values. This means that if we call this function and do not pass in inputs for the last 3 input parameters, then it'll be set to these values by default. Now I'm going to close actor.cpp, and here in the basepawn tick function, I'd like to call addActorLocalOffset each frame just to see how it works. Now we know that the first input parameter is an f vector. It's called delta location. This is the amount of movement we would like to add each time we call this function. So I'm going to create an f vector called delta location. So f vector delta location. Now, I'd like to zero out this vector. In other words, make sure that it's initialized with all zeros. Now, I want a 0 vector. I can pass in 0.f, and x, y, and z will all get 0.f, so this will serve my purposes just fine. Now, I'm going to take delta location.x, and I'm going to change that to 2.f. That way we have a vector with y and z set to 0 and x set to 2. So I'm going to go ahead and pass...
Hey! You being a little munch? Yeah. Okay, you can hang. Delta location dot x equals x.
Delta location into addActorLocalOffset as a sort of experiment. Now I can get away with calling addActorLocalOffset and just passing in the first input parameter, as the other 3 are optional. So I'm going to compile this and see what happens. Now if we go ahead and hit play, notice a couple...
Yo. Feel that, baby.
of things. First of all, look, the tower's moving too. That's because we put this in the tick function for base pawn, and both of these pawns inherit from base pawn. So in fact, all of these pawns were moving. And the interesting thing is that they're all moving in their own x-axis directions. We can see everything move at once from this point of view if we click the drop down next to play and select simulate. This allows us to play the game without possessing any pawns. So if I click simulate, check this out. Every pawn is moving in its own.
Wait a second, how did you simulate?
To play and select simulate.
That's the
This allows us to play the game without possessing any pawns. So if I click simulate, check this out. Every pawn is moving in its own x-axis direction. That is actually pretty weird and pretty cool. So this shows us how add actor local offset works. It moves things in their local directions. Now we can get out of simulate mode by clicking the dropdown and selecting selected viewport, and this will allow us to play in the regular play mode. All right, I'm going to stop this, and we can go back into base pawn, and we can remove this experimental code. I'm going to go ahead and just delete it out of the tick function, so we now know how add actor local offset works. So let's go back to tank.cpp, and here we have the move function. We know that this function is being called every single frame, and we know that value is equal to 1 if we're pressing the W key, and it's -1 if we're pressing the S key, and it's 0 if we're pressing both or neither. So for your challenge, you're going to move the tank using add actor local offset. So in the move function, you're going to create an F vector called delta location. Now make sure to zero out X, Y, and Z. You can do this in any number of ways, such as using one of the various F vector constructors. Now once you've zeroed out all the components, then set its X to the value of value, that float input parameter in the move function. Once you've done this, go ahead and call add actor local offset, passing in delta location. Pause the video.
Caramela, caramela. Hey, 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 got a caramela. Okay, doesn't take 3. Let's just do these. Bronx. Spelled wrong. Fantastic. Term is not evaluated to a function taking one. Um, 0, 0. Oh? What am I doing wrong here?
and do this now. Okay, so I'm back here in the tank.cpp file. Now, I no longer need this UE log, so I'm going to take that out, and I'm going to create an F vector called delta location. Now, I can use one of the F vector constructors. I've already shown you how to create a new vector with all zeros. I'm going to show you another way, which is to initialize this with F vector 0 vector. And this is exactly what it sounds like, a vector with 0 for each component. This is just to show you an alternative way. So we have a 0 vector. Now, I'm going to take delta location.x and set that equal to value. And finally, I can call add actor local offset, passing in delta location. So let's compile this. And back here in the editor, I'm going to take my tank and I'm just going to orient it so that it's facing the world X direction. And then I can hit play. And now clicking in the viewport, if I press the W key, I'm moving forward. And if I press the S key, I'm moving back. If I press both, they cancel each other out and I'm not moving at all. And of course, if I don't press anything, I don't move either. So we now have movement for our tank, but it's a little slow, so we're going to have to do some adjusting. And we're also going to talk about fine-tuning this movement mechanic with our tank. So in summary, we learned about add actor local offset and the difference between world space and local space. In the next video, we're going to continue perfecting this movement mechanic with our tank. I'll see you soon. Hello and welcome back. In this video, we're going to talk about how we can speed up our tank. We'd like to control exactly how fast our tank is moving. And right now, we're just passing in this delta location vector into add actor local offset, and we have no control over how fast the tank is moving. It's actually moving quite slow. So we're going to make a speed variable that we can use to control that speed. And we're also going to take into account the frame rate of our game. As our game is changing frame rate from frame to frame, we actually are not getting consistent movement. So to take that frame rate into account, we're going to talk about something called delta time. So we're here in the editor, and if I hit play, and I start moving the tank around, it's not something you can really notice necessarily, but our tank is not moving in a consistent rate from frame to frame. And the reason is because our frame rate changes. And up here at the top left of the viewport is a little drop down. If I click that, there's a checkbox next to show FPS. FPS means
what you're in. Chill. Relax. Relax. No. Viewport. Perspective. What are the viewport options? No, that's not what I want.
frames per second. If I check this, then at the top right, I see my frames per second, and just below that, how many milliseconds have passed since the last frame. And these values change from frame to frame. If I hit play, you might have missed it, but the frame rate went down and then came back up because during that beginning stage of the game, lots of things were happening. All of the actors were calling their begin play functions, and there's some behind the scenes setup for the world. Now, if I start playing the game, that 120 FPS that I'm getting is changing from frame to frame, even though it hovers around 120. So the reason this causes inconsistent movement is because as the frame rate goes down, those tick updates are being called less often. And if we're moving this tank by the same amount each frame, then we're relying on that frame rate to stay consistent to get that consistent movement. And when the game gets more complicated, the frame rate variations are going to get worse and worse. So we need to make sure that we're adjusting for that by using something called delta time. So what's this mysterious delta time? Well, let's say we have this timeline here, starting at 0 seconds and increasing as time moves on. Now, as time moves on, we're ticking. This means that the tick function is being called, but notice that the tick function is not very consistent. Sometimes it's called very rapidly, and sometimes it's called less often. This is because your computer must make calculations on a frame-by-frame basis, and sometimes those calculations take up more resources from your computer, and that can slow down our frame rate. Now this delta time variable that we have in the tick function is the amount of time that's passed since the last frame. So here it may be 0.1 seconds. It really depends on the CPU usage and how that varies. So as your CPU usage varies, your delta time is also going to vary, and this means that when we have more frames per second, we have more function calls. Now, if we're calling add actor local offset more often, then we're going to see our pawn moving faster, and it won't have a consistent movement rate. So the solution is to scale the movement by delta time. So if delta time is 0.1, and we want to move our pawn by, say, 10 centimeters per second, scaling that movement by 0.1 seconds gives us the exact amount of movement we need for a frame update time of 0.1 seconds. Now consider this part over here where we have a smaller delta time, meaning tick is being called more often. Let's say that delta time here is 0.01 seconds, so tick is being called 10 times more often over here. Well, we could simply scale our movement by 0.01 for this particular frame. And that way, we'll move our pawn by 10 centimeters per second times 0.01 seconds. So therefore, we're moving the pawn a tiny amount since tick is being called much more frequently. Doing this ensures that our pawn will move in a consistent manner independent of the changes in frame rate. So back here in VS Code, let's think about how we like to take care of this issue. We have our delta location vector, and we're setting its x equal to value, but we know we'd like to scale value by delta time. So I'm just going to put a little comment here and say x equals value times delta time.
Free Coke, baby!
Scale value by delta time. Now, once we do this, we're going to make value very small because delta time itself is a very small value, especially if your frame rate is very high. So we're also going to need to scale this by something else, a sort of speed variable. And we can decide what this value should be in order to control the tank's speed. So we have a little bit of pseudocode here to guide us.
Very hard at
we
work.
Just need to implement this by creating
We're getting
a value
this
for speed
tank to
to
move.
get this delta time value. So let's talk about how we can access delta time from the move function. Now, Unreal Engine has multiple ways to get a hold of delta time. In fact, if you look at the tick function that we have in base pawn, delta time is a float input parameter. So if we're working in the tick function, we already have access to delta time. But in tank.cpp, our move function does not have that input parameter. But Unreal Engine has its ways. One way is to access a function called getWorldDeltaSeconds, which exists in a class called uGameplayStatics. As the name suggests, uGameplayStatics has lots of static functions that assist in programming gameplay. GetWorldDeltaSeconds
You were battling some meshes yesterday, yeah? How'd that go?
returns delta time. Now, it has an input parameter here. It takes a world context object. You'll see this a lot in Unreal Engine. A lot of static functions will require a world context object. The world is an object of type uWorld. It's the top-level object of our game. It represents our map, which contains all of the associated objects in our game. Now, static functions such as getWorldDeltaSeconds have no idea which world we're in. We need to tell this function which world we're in so it can access that
world. What world are we in? What world are we in?
And get that delta time value. Now, in order to tell it which world we're in, we can pass in a point.
Yeah, so... I'm working in the blueprints too. I got my tank set up.
To an object that exists in that world.
Yeah, for sure. I definitely utilizing the engine. Just trying to get the basics down though.
While we're working in the tank class, we can pass in the keyword this. This is a keyword that we can use inside
We're in this world.
What the this keyword is a pointer to the instance of any particular object that we're working in. So if we're working in the tank class, this is a pointer to the tank that we're in. So functions that require a world context object can often receive this as the input parameter because the tank we're working in exists in the correct world. So getWorldDeltaSeconds will know which world it's in and can retrieve us the appropriate delta time for that world. So if we're calling getWorldDeltaSeconds from within the pawn class, we're going to pass this in as the world context object.
Yep.
So you now have all the tools you need to control the tank's speed. So what you're going to do is create a speed variable, make this a float, and put it in a private section in the tank class. Now expose this to blueprints so we can adjust it as we're developing, which means you're going to give it a uProperty and use the appropriate uProperty specifiers that correspond to the level of exposure you would like. Now in the move function, we have that bit of pseudocode that we placed in as a comment, so use that as a guide. You're going to take the delta location f vector and scale its x by delta time. We just saw how we can access delta time using uGameplayStatics, and you're also going to scale x by the speed variable. Now because we're using a function in GameplayStatics, you're going to need to include the header file for GameplayStatics. Now I've shown you multiple times how I find the include for a particular class using the Unreal Engine documentation. So I'm going to challenge you to search for uGameplayStatics in the Unreal Engine documentation and find that header file. And if you can't find it, then just find the link in the resources for this video, which will give you the documentation for uGameplayStatics. But try to find it on your own first. Pause the video and control
uGameplayStatics. Statistics? Include Kismet GameplayStatics.h. We want tank.h private. This is going to be a float speed. And actually, you property. Edit anywhere. And base pawn. Blueprint. Is it read and write? Category components, sure. Blueprint, read and write. Oh, it's just read write. Okay, put speed, tank, delta x equals value times shit. What is this? Plug it up. Let's see. This is wrong, but
Control the tank's speed now. Okay, so I have my pseudocode to guide me, and I need to scale value by delta time and by speed. So first, I'm going to create my speed variable. Now back in tank.h, here's where I can place the speed variable. However, if you'll recall from a practice exercise in an earlier lecture, I added a float called speed to the base pawn class. Now, I don't need the speed variable here in base pawn. This was just practice, so I don't really need it here. In fact, I don't need these other int32s that I created to demonstrate the uProperty specifiers, so I'm just going to highlight all of these and delete them from the base pawn class. I don't want them anymore, so they're gone. Now, you might also remember that I referenced that speed variable in the pawn tank blueprint. So I'm going to open up BP pawn tank, and here in the event graph, there's that speed variable that I referenced. Since I no longer need this anymore, I'm going to go ahead and delete those nodes and compile and save my BP pawn tank. Okay, after cleaning up all that,
I've already deleted that.
I'm going back into tank.h to add my speed variable, and this is going to be in the private section here. I'm going to add it just above the move function, and it's going to be a float called speed. Now, I'm going to give it an initial value here. I think I'll try 200.f and see how that works, but since I'd like to be able to edit this in the editor as I'm developing, it's going to get a uProperty macro. And I'd like to be able to edit this on instances and on the default, so I'm going to make it edit anywhere. Now, you didn't have to do this, but I'm giving it a category. I'll create a new category called movement. Now, exposing it to the event graph is optional. I'm going to hold off on that because I don't think I'll need to access it in the event graph. If I need to in the future, I can expose it with blueprint read write or blueprint read only and use that meta allow private access specifier, but for now, I'm not going to. So I have a speed variable, and here in tank.cpp, I'm going to take value and scale it by speed. Now, the last thing to do is scale value by delta time, which means I need uGameplay statics. So here's Unreal Engine's documentation. I'm going to go ahead and search for uGameplay statics, and here it is, uGameplay statics. So I just need to scroll down to the include line and copy this, and back in tank.cpp, I can paste it in. Now that I have access to uGameplay statics, I can get delta time. So I'm going to multiply by uGameplay statics, get world delta sec.
The second is.
And as we saw, this needs a world context object. You can even see with the pop-up, it's asking for a world context object. So I'm going to pass in this. So now that I'm setting delta locations x to value times speed times delta time, I'm going to compile this. So we have a successful compile.
Control S, successful compile, imminent. Successfully compile. Do it. Do it. Compile that ish, baby. Upgrade, 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 upgrade. Uba server, 3 actions. Upgrade me. Compile. Baseball. Wait. Get world delta seconds is not found. New gameplay statics. Not a class or namespace. I disagree.
Need to scroll down to the include line and copy this, and back in tank.cpp, I can paste it in. Now that I have access to gameplay statics, I can get delta time. So I'm going to multiply by gameplay statics, get world delta seconds. And
What was the error that I saw? Identifier not found. I don't really know it's a song, but
as we saw, this needs a world context object. You can even see with the
I don't think this is going to do it. I'm just rerunning. Alright, now class or namespace. Bruh. And
pop-up, it's asking for a world context object. So I'm going to pass in this. So now that I'm setting delta locations x to value times speed times delta
this is
time, I'm going to compile this. So we have a successful compile. So back here in the editor, I can go into bp-pon.
I don't have a successful compile. That's the issue. Go to mission time and get world. I guess we're going to old Google. Kids hashtag include Kismet / gameplay. Oh, you know what? Is that what it is?
To value.
Yeah. That was it. Come on. Succeed. Succeed, come on.
Times speed times delta time, I'm going to compile this. So we have a successful compile. So back here in the editor, I can go into bp-pon tank, and there's my speed right there. And if I select the instance of the tank in the world, I can search in the details panel for movement, and there's the speed. And I can set it to any value I like. If I crank this up and hit play, then I'm moving quite a...
Wait, hold it.
And there's my speed right there. And if I select... I'm going to compile this. So we have a successful compile. So back here in the editor, I can go into bp-pon tank. tank, and there's my speed right there. And if I select
Um, that is my speed. Dash 10 to virtual movement. There it is. Oh, that's 2,000? Right. I did say 2,000. Okay.
the instance of the tank in the world, I can search in the details panel for movement, and there's the speed, and I can set it to any value I like. If I crank this up and hit play, then I'm moving quite a bit faster. So this is the advantage of exposing the variable to blueprints. I can experiment and find a good speed that works for me.
Gross.
All right, so that's looking great. I'm going to go ahead and stop showing the FPS now. And now we have our speed variable, and we can change it, and that change will be reflected in the movement of my pawn. So we're now controlling the movement speed of our tank, and we have a nice speed variable that we expose to blueprints, and we can set that as we're developing and experiment with its value. We also learned about delta time and why it's important to scale our movement by delta time so it's frame rate independent. As the frame rate changes, we'll still get smooth, consistent movement with our tank. So looking back at our section plan, we're almost done with our first bullet point. We've created a tank and it can move throughout the world. Our second point is to handle input with WASD keyboard movement and mouse input as well. We've got that W and S part down, but we still need to be able to use the A and D keys, and we're going to use those to rotate the tank. So we're making good progress. In the videos to come, we'll work on finishing our ability to move the tank. I'll see you soon.
Okay, I'm stopping here. But I'm going to save. I'm just going to rebuild. Because it's been maybe like, I don't know, 15 minutes trying to figure out why. I had to like basically redo what I did yesterday. So hopefully rebuilding today before I'm done saves me time tomorrow. No existing make file. Come on, baby, build. Build, baby, build. There we go. Cat in the background. Kona, what are you doing? Got dizzy suddenly. Jam. Green Coke, take care of yourself. I'm switching over. I'm doing Minecraft now, Green Coke.